We, Team Alchemists from Viva Institute of Technology, are here to present our project on violence reduction using CCTV and drones. Here we have Sufyan Parker, Sushant Pawar, Chaitanya Dandekar, and Manish Pawar. In India, crime has always been a serious issue, and it is difficult to tackle it due to lack of technology. As we know, there's been a monumental rise in the crime rate in India, and with no measures employed to detect crime in real time, the suspects escape custody. Also, due to the lack of proper substantial proof and records, the criminal isn't convicted of his crimes. Even after having a CCTV recording of the crime scene, there are still many technological challenges, mainly the poor quality of the recordings and the inability of the CCTV to capture information beyond its scope of the field of view. Say, the camera was of a good quality, the crime scene was also captured, but the authorities have to watch the entire footage in batch processing of multiple videos, thus rendering the cops to reach the crime scene hours later than the crime has actually taken place.
The current security techniques can't be trusted, as it only records the footage of the crime scene with very little focus on determining any kind of criminal act. Sometimes the authorities fail to recognize the target due to lack of management and technical support.
As we can see, if there's a huge crowd or a mob fighting, it would be difficult to categorize the attacker or the one who's been attacked, since the information being taken is too much.
Yeah, and sometimes there might be also a case where the crime taking place is very far from the CCTV, so we have a proposed network architecture that would help solve this problem.
Our main focus is to aid law enforcement agencies to avoid the outbreak of violence by monitoring crime scenes and alerting the respective security officials. We present a smart way to reduce violence using a CCTV's live video feed. Our algorithm is capable to identify any criminal activity in that particular video feed, thus aiding in detection and recognition of any criminal activity. This information is then shared with the police as well as the drone via the cloud. This information is then used by the drone to identify, track, and chase the suspect until he or she gets caught. A dynamically navigated system in the drone will help in effective tracking and chasing of the suspect. Also, simultaneously, a live video feed will be channeled to the cops in order to help them catch the criminal.
Now, for the fight-no-fight detection, the dataset used here is collected from YouTube and CCTV videos of 150 fight and non-fight sequences each. It is collected from various locations like street, bus, cafe, etc., with each video being 2 to 3 seconds long. The model takes 2 consecutive input frames, as you can see here. It's from a live CCTV feed, processed by a pre-trained CNN called Darknet. Now, this Darknet has some degradation issues. To deal with it, we added 2 extra CNN in the pipeline to learn the local motion features. Then, these image vectors are passed to an LSTM layer flattened later to output fight-no-fight in a live feed.
Here we have a demo working on our project. We can see CCTV footage from a certain street. The first algorithm is fight-non-fight detection, wherein the background color depicts the type of activity detected by the algorithm in that video. If non-fight, then green, and red if violence or fight is detected in that particular video feed.
And note that this identification is done on AWS Cloud and not on CCTV itself. CCTV's job is only to capture high resolution live feed and pass it to the cloud.
That's right. Now it's passed to a PoseNet, which is basically a human pose estimation model, wherein it detects the type of actions performed by each human like sit, stand, walk, push, run, fight, etc. Here we have the output of that video frame wherein the criminal has got a label of fight. Later on, we have weapon detection using computer vision that enables us to identify presence of a weapon if any, and this helps us to recognize the threat level of a particular crime scene, which helps us to prioritize the importance and attention that must be given.
Then, the detected suspect is extracted from frames using viable image segmentation methods. Each attacker's information is stored in a separate folder so that it could be easily distinguished. Then, this is shared on a cloud to all the other CCTVs in the vicinity and the nearest police department. And if the worst possible scenario comes, like the suspect escaping in an unidentified area or in a car, then the nearest police station will deploy the drone where the cops will have the authority over the drone.
And yes, the drone has access to the cloud so that it can detect the suspect with its inbuilt OpenCV. Once given the command, the drone uses Maps API to get the location of the CCTV where the crime took place. Here, you can see that the drone has successfully detected the suspect. So, expanding at a larger scale, there is an interconnected network of CCTVs across the city. Let's consider a junction. Here, 4 of the CCTVs will be installed or kinda upgraded at a junction considering their field of view. And similarly, this kind of tetrad will be placed at each junction. Here, you can see that this CCTV is covering this much area and this CCTV is covering this much area, so that there is no area which is left uncovered by any CCTVs.
So this is a scatter where all the CCTVs are connected to a common cloud using AWS Lambda and Firebase API.
Yes. Now, if one CCTV detects suspect in this vicinity, then as we saw earlier, due to a decentralized cloud, this info is accessible by all other CCTVs. So, even if the suspect escapes one CCTV's field, he still will be detected and be watched by all the other CCTVs.
And as we said, we have one drone ready at each police station for worst case scenarios. We have one drone to cover 4 such junctions. Also, taking from a budget perspective, it's feasible to have one drone for a larger area than having multiple drones, creating chaos.
Correct. And so to analyze, we took a smart city of Gandhinagar where each drone with a hexagonal zone is provided, thus covering the entire city. Our primary targeted market is the law enforcement agency or the police organization. Later on, this can be expanded to universities and hospitals. Our goal is to reduce crimes and assist law enforcement agencies in all legal proceedings to prove that the convicted one is guilty. The strategy that we have in mind is to spread the awareness and let the people of this nation know that they can feel safe in the night.
As mentioned earlier, the prime target audience of this project would be the government bodies and then the schools, hospitals, universities or private organizations. The message that we want to convey through this is security is not a product but a process. Lastly, we'd like to extend our thanks from the team The Alchemists.